This is my intermediate level, slightly technical level of inverter, solar panel, battery overview. So obviously that's a solar panel. So you can see there's a distinct line down the middle. This is broken into two halves. So there's this half over here. This is called a split panel, and then this half. So in the back, there's something called a diode. Think of it like an on-off switch. If this section on this side is significantly shaded, what happens is this half over here turns off, and it only uses this half for electricity. So preferably when you install panels, your most production will be at an angle of about 34 degrees north. So if you imagine going, you can use your phone as your level to tilt it at the right angle, but often if you just put your phone at an angle, you can put a level on your phone to see the angle. Sometimes your roof is, even if it's not a significant angle, as long as the dirt is running off and it's looking relatively north or east or west, never south, because what happens when it's pointing south, it's always kind of looking away from the sun. So what happens is it hits at such an acute angle, which means it hits at such an angle that it basically bounces off for the most part. So the solar panel ends up producing very little power. Each of these cells over here, you'll see there's a string down here of conducting electricity. So what happens is all these little strips over here add up together and add electricity together. So if you think of all of these adding voltage, so you start with 1, 2, 3, all the way up, then you add some extra. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So imagine this was a 36 volt system. Each over here would add whatever voltage that is. So 36 divided by 9. So each section over here would add, let's say, just over 3.6, let's say 4 volts, 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 4 volts. That actually does add up to 36. So each of these sections adds a little bit more voltage. So that's 4, that becomes 8, 12, all the way up to 36. And then it repeats the same thing on that side. That then adds those two electricities in parallel. So if you think of how much electricity this thing makes, how the voltage of electricity is how tall it is, and the current of the electricity is how long it is. So how much up area times the number of sideways area. So this is your current, so that's your amps, and this section here is your voltage. So how much area is inside there equals how much power that panel makes. So that particular panel is a 500 watt panel. So that's a solar panel. Then you've got an inverter. So this is a lithium battery over here. So this is a 2,500 watt hour battery. So that is a 500 watt panel. So that's a 2,500 watt hour battery. So how long that battery lasts depends on a few factors. So one of the factors is how quickly am I taking electricity from this battery and pouring it into my household electricity, which comes via the inverter. So the quicker you're drawing on that, and that's basically called the discharge or the charge rate, that's measured in kind of C. So the a C rating of 1 equals 100% of the capacity in 1 hour. So in this particular instance, this battery, if I was discharging at 1 C, I would be discharging 2,500 watts in 1 hour. If I'm discharging at 0.5 C, I would be discharging at 1,250 watt hours per hour. And if I was discharging at, let's say, 20%, that particular battery could, inverted commas, last 5 hours, because 20%, 5 times adds up to 100%. So that's your charge stroke discharge rate for your battery. The inverter, if you've watched my other videos, the solar panel is like the stream or the windmill. The battery is like the JoJo tank. The inverter is the size of the pipe and where in the battery that pipe fits. So the lithium batteries, you typically take up to 90-95% of the batteries. Some of the new ones you can literally even take, inverted commas, 100%. It's not technically 100%, but it's, let's say, 100%. for all extensive purposes. That is the inverter. How fat your pipe is coming out of your JoJo tank over here determines how long that battery lasts and what is it capable of. So if my pipe is coming out of there is 250, then that at full pressure would last 10 hours, because that's 2,500 liters. The hole's only doing 250 liters an hour or 250 watts an hour. Therefore, to 100% complete empty would take 10 hours, assuming I leave 20% in the battery. So I'm using 80%, so that's called depth of discharge. Depth of discharge is how much from the top am I emptying. So the depth of discharge is here is 80%, but the state of charge when it's 80% empty is 20%. So the 20% state of charge plus the 80% discharge, depth of discharge, is equal to 100% of that battery's capacity. So state of charge and depth of discharge are, the one is 100%, mine is the other. So 100% equals state of charge plus depth of discharge. The inverter, in this case it's the Schneider Hermaya. It's an 850 VA. For most extensive purposes, just think of 850 VA as being 850 watts. There's something called power factor correction, which has kind of got leading and lagging, current versus voltage. I'm not going to go into that in this video, but that's basically power factor is taken into consideration with that. And so that pours in at 500, that's 2,500, that one is 850. So bear in mind that inverters typically do not run close to capacity. So normally a house has got like a 5 kilowatt, this is an 850, so 5 kilowatt is 5,000. Even with your kettle on, your stove on, things that basically are resistive, maybe your toaster or your kettle, all of those things on concurrently, you'll probably hit about 3.5 kilowatts. And so you've got 5,000, you're using 3,500. A lot of the Solis and the SunSync inverters like this can do a 200% of capacity. So if it's a 5 kilowatt inverter, it can actually do 10,000 for a while. So 5 kW, K being 1,000. So 5 kilowatt is 5,000 watts. 10 kilowatt is 10,000 watts. Typical sizes for inverters: 3 kilowatts, 5 kilowatts, 8 kilowatts, 10 kilowatts, 12 kilowatts. Battery capacity for most residential houses are generally in like 5,000 increments. Good batteries to get: Freedom One, Pylontech, very, very good. Chinese battery, but brilliant battery. They did a study in Australia with 26 batteries. Only 4% of those batteries, so basically 1 out of 24 batteries passed the test. Sorry, 1 out of 26 batteries passed the test. That battery was the Pylontech. I think it was the US 2000 or 3000C in this particular instance. They tested it over 8 years, including Powerwalls and very, very fancy batteries. Technically 2 batteries passed. There was the Sony lithium battery and the Pylontech. The Sony battery you can't buy, so technically the available batteries are only the Pylontech, and that's out of literally 25 batteries, that's the only one to have passed the 8-year test. Pouring in, storage capacity, pouring out. So bear in mind, in daytime you're pouring in and pouring out. So if that's pouring in at 2,000 and you're only using it at 600, your stored capacity of this is 1,400 per hour.